Good evening, everybody. Welcome to Chem 1211 with your host, me, Dr. White. Hi, tonight I'm going to just briefly go through some of the stuff for test 2 and the final exam. Remember, next week, July 29th, 30th, and the 31st, that's next Monday, Tuesday, and Wednesday, you have to take test number 2 and the final exam at the Glen Ellen Testing Center. That's the only place you can take it. The Glen Ellen Testing Center on Monday, Tuesday, and Wednesday are open from 9 a.m. till 5 p.m. Now, because it's finals week, I get there early because there's probably going to be a long line. Also, figure it's about 65 minutes for my test 2. The ACS exam is a timed exam. You'll have 55 minutes. Now, let's go through something. You go to Blackboard. Here's the information about test 2. It covers the whole semester, sort of my final. And there's 27 problems, 12 pages, 5 multiple choice. Some of the questions are multiple part. Material covered from quiz 1 and 2, 20 points, test 1, 36, quiz 3 and 4, 29, 5 and 6, 22, new material 3, it adds up to 110, 10, yes, 10 bonus points. All right, remember on my test, use proper significant figures for all calculated answers and use 3 significant figures for all atomic masses. I highly recommend that you show your work. If you make a mistake and you show your work and I can say, oh, this is a minor mistake, I can give you partial credit. Now, you'll also next week be taking the Chem 1211 final exam. This is a American Chemical Society standardized exam. It's multiple choice. Here's a video that will tell you more about it. You'll have 60 questions. You'll be given 55 minutes to complete it. It covers the whole semester. Now, you'll need a number 2 pencil or a soft lead pencil to mark your answers on the Scantron card. I also recommend bring a good eraser. All right, the other thing, you will need a non-programmable scientific calculator. Bring your own, because if they give you one, you may not know how to use it. All right, you'll be given a list, but I just want to go over it. You only complete the first section, which are 60 questions with a 55-minute time limit. And you'll only be allowed non-programmable calculator, like the one I've been using all semester, this TI 30XIIS, which I've had for many years. It's like a tank. And when you get the Scantron card, print. Don't write cursive. Print your name, instructor name, Dr. White, the course and section number, and for us, it's CHEMI 1211 NET02 on the front of the Scantron card. Now, listen carefully. Do not write anything in the booklets. I reserve the right to subtract up to 50 points from your final total for anybody who writes in the booklet. And trust me, somebody writes in a booklet, the chairman of the department collects them and checks them because we reuse them every year, and she gets back to the faculty member. And since there'll be a number on there, a number on your Scantron, she'll know which book each student used. If you do find any marks in the pages for problems through 60. After you're done, let the staff at the testing center know that was in there and you didn't do that. Again, if you find any marks, don't erase them, but just show the people at the center, say, I didn't do this, it was in there, and my instructor told me you should be made aware of that. All right, let's first of all, real quick, a little advice about the ACS final. Since it's a time final, go through and do all the problems where you don't have to do calculations, the ones that are quick to do. Next, do the ones that you have to calculate. Check units in your answer. Use your good buddy, your good friend, unit analysis. And the last thing, which is why I don't like multiple choice tests, for this one, if you put down the wrong answer, you're not penalized, you just don't get points. Well, if there are a few you don't know, yes, I hate to say that, but yeah, so listen carefully. When you take the ACS final, go through and do all the problems where you don't have to do any calculations. Then go back and do those. And then if you're unsure of anything, guess. All right. Now, the next thing I'd like to remind you, if you go to my Chem 1211 channel for this semester, go look at these videos where I do a review for the different tests and quiz. And you can open each one. And if you click on more, here, this one is for quiz 5 and 6. Go back and watch them. Also do the practice problems. So I'd highly recommend you watch all these. The other thing I would recommend to help you do well is, other than, well, actually, all the quizzes, and I sent out a blank test number 1 to each of you. Use those as practice problems. In the videos I have posted, I sent you emails. The answers for all those quizzes and test 1 are available to you. So you can use that as practice problems. Practice. Now, for my test number 2, I will have a sheets at the end, like I've done my quizzes and tests, important information. Now, the ACS doesn't give you that. That's just that. But by now, I think you know the ideal gas law, PV equal nRT, Boyle's law, P1 times V1 equal P2 times V2. You know how to do mole problems. You know 1 mole equals Avogadro's number of molecules or atoms. And the molecular weight of a compound equals 1 mole of that compound. And those are the key ones, other than 760 millimeters of mercury equals 760 torr equal 1 atmosphere. How to go from degrees F to degrees C and back and forth. That also you should remember. Now, advice. Next week, I would highly recommend, after you studied, go in, first take my test number 2. Take a break afterward, and then come right back and take the ACS final. When in the summer I teach this face-to-face, I give my test 2 on the last day. It's a 2-hour lecture, or we have actually 3. I give the test number 2. We take a 15-minute break, then they come back and we do the ACS final, and we're done. Well, we're not face-to-face, which is why you have to go to the testing center. All right, let's go through a few things I just want to cover quickly. All right, let's go through some things. Now, for my test and also for the ACS test, you'll be given a periodic table just like you've used all semester, just the symbols, the atomic number, and the weight. And you should know for my test what the symbols these are and what they are. Now, for my test, and I think the ACS, I don't remember, I haven't seen one in a couple of years. Don't forget about significant figures. You know how to do that already. And remember, for multiplication division, excuse me, you get the same number of significant figures in your answer as the number that has the fewest significant figures in your answer. Now, when we come to chapter 3, remember the 3 states of matter: solid, liquid, gas. Also remember, solid has definite shape, definite volume. Liquid has indefinite shape, definite volume, and gas has indefinite shape, definite volume. Now, we talked about mixtures, and there are 2 types, and that is, I don't have it on here, homogeneous and heterogeneous. Homogeneous, it's the same throughout. Like if you had, I don't know, water and sugar mixed together. And there's heterogeneous where it's not the same throughout, like separate layers. If you put sand into water, the sand will go all the way to the bottom. All right, the temperature scale conversions. For my test, I will give you that. For the ACS, they don't, but try and memorize it. It's pretty straightforward. All right, we talked about atoms, smallest element of a particle, small. Let me try that again. Backed up the tape. The smallest particle of an element that retains the characteristics of that element. Now remember, there are 3 subatomic particles. That's electrons, protons, and neutrons. And electrons have a negative charge, protons have a positive, neutrons no charge. And remember, the center of the atom is called the nucleus, and that's where the protons and neutrons are. And all around outside of that are the electrons. And Rutherford's gold foil experiments help clarify the nucleus. And Thomson's cathode ray experiments showed electrons had a negative charge. Opening up the periodic table. All right, well, we have this on the screen. Remember, this is the periodic table. You have the element symbol like hydrogen. In the upper right-hand corner is the atomic number. The atomic number gives you the number of electrons and protons. Underneath is the atomic weight. The number above the column is the valence electron, the outermost electrons. Hi. All right. Now, when you're looking at the periodic table, you should know the first column is the alkali metals. The second column is the alkaline earth metals. And then all the way over, you have the halogens. By the way, I charge extra if you're in a car. And then the noble gases all the way. And you should be able to give examples of alkali metals, alkaline earth metals, halogens, and the noble gases. Now, I didn't talk too much about it, but the ACS might. You should know metal is something that has characteristics of luster, thermal conductivity, conducts heat, conducts electricity, and malleable means you can pound it down so it's real thin. All right, here are examples of metal: aluminum, copper, iron, silver, gold, and so on. All right, let's continue. I'm just doing a quick review. All right, next, for test number 1, you should know about the electron shells. Shell 1, 2, 3, 4. Shell 1 has 1 subshell, 2, 2, 3, 3, 4, 4. By the way, I will be posting this on my YouTube channel, this review. And the subshells are S, P, D, and F. S can have 2, P, 6, D, 10, F, 14. And you start from the lowest energy as you go down the tables, you go to the highest. When we talked about the electron configuration, and that's the statement, how many electrons you can have in each subshell. Remember, a subshell is a number and a letter, and I would recommend you go back and look at the video for the review for test number 1 to see how to do that. Now, the valence electrons are the outermost electrons. And that, as I said earlier, you can find on top of the periodic table column for each element. Now, when we talk about valence electrons, we show them by using a Lewis structure, sometimes called electron dot structure or dot structure. And you only have valence electrons, and you put 1 electron on each side of the chemical symbol before you pair them up. Now, there's 2 types of chemical bonds: ionic bond, which results from sharing 1 or more electrons from one atom or a group of atoms to another atom or group of atoms, and a covalent bond. And a covalent bond is sharing of pairs, 1 or more pairs of electrons. And the octet rule is atoms lose electrons, gain, lose, or share electrons such a way that they have 8 valence electrons, except for hydrogen, and that has 2. Now, I taught you, I'm not going to go over it now. You can go back and look at the video for test number 1 review, how to determine what charge a element will have when it forms an ion. Now, for ionic compounds, the simplest formula is when you have a net 0 charge. And if I have sodium plus and fluorine minus, this is a +1, this is a -1. When you put them together in such a way, it has to add up to 0. So 1 of those and 1 of those, and that's how you do it. Now, if you have something like this, This is a magnesium +2. And this is a polyatomic ion nitrate, so -1. It has to add up to 0. You can't change the charge, but you can change how many. If I have a +2, I need a -2. So -1 times 2 is -2. How do you show that? 1 magnesium. When you have a polyatomic ion like that, more than one, you put it in a bracket like this, and that's how you do it. Remember, all molecules have a net zero charge. Now, I taught you about Lewis structures for molecular compounds. We have bonded electrons and non-bonding electrons. Remember, there are 3 types of covalent bonds: single bond, double bond, triple bond. Single bond has share 1 pair of electrons, double bond 2 pair, triple bond 3 pair. And I showed you how to do the Lewis structure for that. And let's do one, say, oxygen gas. Oxygen has 6 valence electrons. And there are 2 of them. And here's the Lewis structure for each one. Now, this oxygen atom tells its friend, oh, look, I have 1, 2 unpaired electrons. You have 2 unpaired electrons. Let's share. And they do. And the non-bonding electrons are still there. And therefore, you have a double bond between the 2 oxygen atoms. All right, next I talked about moles. And the mole is the chemist's common unit. And here are various relationships of moles. Now, I would highly recommend that you go back. I'm not going to do it tonight. Well, maybe I will. You look at Chapter 6 practice problems. If we look at number 7, how many molecules are in 23.45 moles of water? Now, when you take the ACS final, you can't write in a booklet, but they will give you scratch paper that you can write on to do your work like this. And as I've taught you all semester, a problem like this you have to calculate, find out what are you trying to find, what are you given? This is what we're given. What units are we trying to find? Molecules of water. And now you use your good friend, your good buddy, unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. And where do you get a relationship between moles of a compound and molecules? 1 mole of a compound equals Avogadro's number 6.02 times 10 to the 23rd. So I do this, do the math, 4 significant, 3 exact number, and I get the answer. A lot of you had problems with this. Go back and review this. Now, we talked about molecular weight. The molecular weight is the sum of all atomic weights, atomic weight you get from the periodic table. And for water, you have 2 hydrogen, 1 oxygen. Each hydrogen has atomic weight of 1.01. Each oxygen 16.0. Do the math, add it up. Remember, when you're using significant figures, You get the same number of significant figures to the right of the decimal as the number with the fewest that you're adding. This is 2, this is 1. Therefore, we should only have 1. Keep the 0, use 2 to round off. It's 4 or less when we drop it. Now, if we look at 15, how many moles are 34.56 grams of water? Again, with these type of calculations, what are you being asked to find? And I use the question mark in front to let me know that's what I'm trying to find, moles of water. Speaking about moles of water, I just had some. Oh, that was lame. But anyways, and we're given 34.65 grams of water. Now, we have grams of water. We're trying to get the moles of water. If there's a single ratio to multiply that, what would it be? Use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top. Whatever we're trying to get rid of goes underneath. And we should remember, it'll be important information in my test too, but for the ACS, you'll have to remember it. 1 mole equals the molecular weight of a compound, and the molecular weight is the sum of all atomic weights. Well, here we just did the molecular weight of water, 18.0. So for every 1 mole, there's 18.0 grams of water, 3, 4 significant, 3 exact number, 3 significant figures. Now, I won't go through it because most of you did pretty good on my test, and I don't know about the ACS. You should know how to balance the chemical equation. We went through that. Go back and look at review for test 1 if you need more help. Now, let's look at number 4 from chapter 8, practice problems. For the following balanced equation, how many grams of hydrogen are needed to make 125.6 grams of HCl, hydrochloric acid? And there we have grams of hydrogen. We're given grams of HCl. You need 3 steps. Step 1, whatever you're given in weight, you convert to moles. And I do it here. Remember, 1 mole equals the molecular weight. Now, when we have moles of HCl, we're trying to get to eventually grams of hydrogen. What we'll do in step 2, moles of HCl to moles of hydrogen. And here's what we start with. Here's what we're trying to get to. And how do you get this ratio? Whatever you're trying to get to goes on top. Whatever you're trying to get rid of goes underneath. But where do we get the numbers? Remember, the coefficients in front of a balanced chemical equation give you molar relationships. And that tells you 1 mole of a compound, in this case, 1 mole of hydrogen, when there's no number, it's 1, reacts with 1 mole of chlorine to make 2 moles of HCl, hydrochloric acid. 1 mole of hydrogen makes 2 moles of HCl. And these are exact numbers. And that's how you get this number. But are we done? No, we're trying to get to grams of hydrogen. And so we have moles of hydrogen. We want to get the grams of hydrogen. Again, use unit analysis. On top of the ratio, goes grams of hydrogen. Underneath goes moles. Where do we get that? 1 mole of a compound equals the molecular weight. The molecular weight is the sum of all atomic weights in that molecule. And there are two hydrogens. Each hydrogen has atomic weight 1.01. So it's 202. Do the math, and that's the answer. Now, as a special gift in my test too, there'll be no limiting reactants questions. There'll be no limiting reactants questions. But you should know how to do what I've just talked about and know how to balance chemical equations. Now, next I talked about gases. Remember, and this should be, 760 torr equals 760 millimeters of mercury equals 1 atmosphere. I taught you also earlier, but you'll need it here. Kelvin equals degrees C plus 273. I showed you Boyle's law, P1 equal V1 equal P2 equal V2, P1 initial pressure, V1 initial volume, P2 final pressure, V2 final volume. And I showed you how, if you're given P1 and V1 and either P2 or V2, how to solve for the other. Next, I taught you the ideal gas law, PV equal nRT. And the ideal gas law, remember, whatever you're calculating, like when you did it on my quiz 3, 15 points, yep, 15 points. Pressure had to be in atmosphere, volume in liters, moles is N, temperature had to be in Kelvin, and then the universal gas law constant is 0.0821 atmospheres, liters, mole K. And you learned how to solve for various things like volume or pressure. You also learned that in the winter, temperature goes down, the pressure goes down. PV equal nRT tells you that. Time out for a break. It's a junk call. Hang in there. All right. And don't forget to use, and the summer, temperature goes up, pressure goes up, which is why you should check your tires then too. And then I taught you Dalton's law of partial pressures, that the total pressure is the sum of the partial pressures of each gas. The partial pressure is the pressure of each gas in the mixture if it were alone. I'm going through this very quickly, and the reason I'm doing that is because you can go back and look at the video I just talked about concerning each quiz and test number 1. Next, in test quiz 4, I talked about solutions. Solutions has a solvent, that's the component present in the greatest amount, and a solute, all the other components. Talked about colloidal dispersions. You got to see my flashlight. Oh, I got to turn it on. I have a nice collection of custom flashlights. But anyways, remember, colloidal dispersion is not a true solution. How do you know? Because it scatters light, not like a solution. And examples would be mayonnaise, blood, would be 2 of them are latex flame. Don't forget about like dissolves like. And then here are the various definitions of types of solutions. Now, important concept is molarity. And molarity is concentration, how much of a solute is in that solution. And it's defined by moles of solute per 1 liter solution. 1 liter equals 1,000 milliliters, and you have moles of solute per 1,000 milliliters. Now, I showed you how to do calculations. Go back and look at quiz number 4 video, and you'll see, and also the problem set for this area, how to do the two-step. In fact, let's see if I have it open. No, I don't. So know how to do that. Hang in there. I'll eventually find what I'm looking for. All right, now I just went through this so you can look at the video. You should know the collision theory, rate of reaction, how fast a reaction makes reactants or the makes products or the reactants are consumed, used up. Remember that what are factors that influence the rate of reaction, whether something's a solid, liquid, or gas, how much of the reactants, the more reactants, the faster. A rule of thumb, mostly true, is that for every 10 degrees increase, the reaction rate doubles. Don't forget, catalysts make a reaction go faster. They work by lowering the activation energy. And I showed you, and go back and look at the video for quiz 5, how to do an exothermic reaction energy diagram. Exothermic heat is on the right, and an endothermic reaction energy diagram where heat under reaction is on the left. Now, we talked about chemical equilibrium, and that's where you have two reactions happening at the same time, forward and reverse. And at equilibrium, the rate forward and the rate reverse, which way did it go? Which way? No, anyways, forward and reverse are the same. Now, the equilibrium constant is calculated using this formula for this example of a chemical equilibrium. And you see the double-headed arrows, two of them, one to the right, one to the left. What that tells you is W moles of A react with X moles of B to make Y moles of C and Z moles of D, going this way. But at the same time, it goes backward. C Y moles plus Z moles of D react to make X moles of B and W of A. Now, here's the equilibrium constant. Don't forget, it's times C concentration to the Y power times D to the Z power divided by A to W and B to the X. Now, in the equilibrium constant, the larger it is above 1, the more the product C and D you make. The smaller it is, less than 1, the more A and B stay there and aren't reacted, which is what's here. And then I taught you the Chatelain's principle, which is an equilibrium under stress shifts to the side to remove that stress. And you should know if you add things or take things, what happens to the equilibrium. And for exothermic and endothermic, what happens when you change the temperature. Remember, when you put something in an ice bath, you're removing heat. When you put something in a boiling water bath or hot water, you're adding heat. And that will affect the equilibrium. And you should be familiar with this. And finally, I talked about Bronsted-Lowry acids and bases for quiz 6. And you should know a Bronsted-Lowry acid is a proton donor. A Bronsted-Lowry base is a proton acceptor. You should know here's some acids, here's some bases. Because of the association of water, we have the ionization for constant for water, which is this. And you can use that to calculate the concentration of these things. Now, acidic solution, the hydronium ion concentration is greater than the hydroxide ion concentration. For a basic solution, the hydroxide is greater than the hydronium. And for a neutral solution, the hydronium H3O plus are equal to the hydroxide. Now, this is sort of hard to work with in your mind. So someone came up with a pH constant. And the pH is minus the log of the hydronium ion concentration. And for my gift to you this semester, when H3O plus is 1.0 times 10 to the minus X, pH is X. Now, this is important. When you're at 7 pH, it's neutral solution. Below 7 is acidic, the lower towards 0, the more acidic. Above 7 is basic. The closer to 14, the more basic it is. If you start out with a pH 7 and add an acid to water solution, the pH will drop because it becomes more acidic. If you're at pH 7, water solution, and you add a base to that, the pH goes up because you're making it basic. I talked about buffers and I showed you about titrations. At titrations, moles of acid equal moles of base. Now, one last thing I didn't talk about in a review, but I'll mention it now, and that's nuclear radiation or nuclear chemistry. Now, there are two types of main nuclear reactions: fusion and I'm getting a mental break here, fission. All right, fission is where you bring two big molecules together and give off a lot of energy. And that happens like the atomic bomb and a uranium atomic bomb. Now, the fusion, the U there, is when you take, actually, let me start again, back it up. Fission, big radioactive particle, and it separates into smaller ones, and it gives off a lot of energy like the atomic bomb, the uranium atomic bomb. Now, fusion, the U, you take two little atoms, hydrogen, bring them together real fast, and it gives off a lot of energy. And that's what happens on the sun. So in a nuclear reactors on the planet here, we use fission, there you go, uranium separating to make heat. And on the sun, little hydrogens coming together to make a lot of heat. That's fusion. And with that, I'm done. It's been a pleasure having you in my class. Don't forget, one, hand in your labs. I promise by this Monday, and I'll put out an email to this an announcement, I will have all the labs that you've handed in as of Saturday or Sunday morning graded. Get your labs in. Also, don't forget, next week, either Monday, Tuesday, or Wednesday, you need to take at the Glen Ellen Testing Center my test number 2, and you also need to take the Chem 1211 standardized ACS final. I would highly recommend do it the same day. Now, the testing center opens at 9, closes at 5. There's going to be a long line, so I get there early. And don't go there at 5 o'clock because they're closing, and they're not going to wait around an hour for you to take a test or the final. So with that, I'm going to say have a great weekend. Study for test 2, study for the final, and don't forget, hand in your labs. If you have any questions, always feel free to email me. Next Monday, yes, I will have office hour. And with that, I'll say, gang gesund. Bye now.